What's up, everybody? Alright, Russ with rwgresearch.com. I'm going to show you something cool today. I think you'll like this. So 3D printing, right? I've been 3D printing for a while now on this guy that I built maybe 2 years ago now. And a little bit ago there was a gentleman in here and he asked me some questions. He was seeing this thing. He had a friend that needed some help with something, and so he asked me if I could help, and I said maybe. So here's what we got. A friend of his has a motorcycle, and I'm doing this as a favor, but also as a little bit of a test. So I'm going to get this part out. So he's got this motorcycle, and on the front there's a gear that goes to the speedometer. Alright, it looks like this. And that gear is actually this one right here. And, well, quite frankly, you can see it's snapped off. So he said, do you think you could 3D print one of these? I was like, maybe. So I said, you get me the right kind of filament, because this is nylon. I said, you get me the right kind of nylon filament and I'll see if I can print you one. So this is what the wheel looks like, in case you're curious. This is off of a Honda Matic 1983. And you can see those two little ears inside there. Right there. There's an ear there and an ear there. Those ears are supposed to be inside of a little set that's right here. Well, unfortunately, those broke off, and he thinks that somebody replaced the wheel and put that back on and put it on wrong and then tightened it and broke them off. So inside there's another gear. This is where the little piece comes out and goes up to the speedometer. And this guy just fits right inside there. And I said, yeah, give me some nylon filament. So basically, I have some nylon filament here. This is, I'll give you the specs later because I don't really know. I've got it covered up. But this is the stuff. And this is the first time I've ever printed with anything except for ABS. I haven't even printed with PLA, believe it or not. I just haven't. So I will put this on the end of the video, but I did print a single layered object to do some testing. And man, I can't break this stuff. Oh, it just stretches, but it's crazy how strong this stuff is. So watch the end of the video. You'll get to see some stress testing. But I just wanted to kind of make this video and show you the practical uses for 3D printing. And this is day 2, I guess, because I just tried one of these prints just to see what would happen. So this is a discontinued part. You might be able to find a used one somewhere. You guys might even have one in your backyard. I don't know. Junker motorcycle. Who knows? But nonetheless, this is going to be about printing with nylon, and if I can actually achieve the goal to make this gear. Alright? So that's step 1. Test the filament. That's what I've been doing. And step 2 will be designing and then trying to print out this gear and see if it works. Alright. Peace. See you soon. Oh ho ho! This happens every once in a while. Don't really know why. Anyway, look at this. It is basically complete. This is the gear. Sorry about the poor lighting. So, I told you guys in the beginning of this video I was trying to make a gear, and this is basically the finished gear. This one actually was printed at a layer height of 0.04785, I believe, because I wanted to see how thin of the layers I can print, and it actually turned out worse. The best one I printed so far was around 0.8, 0.6, but you gotta try it sometimes to figure out how it's going to work out. So here is there's the finished one, I guess. I'm going to print one more at a little bit higher height. So here's the original. And here's what I did. I went to Google SketchUp, and there's a gear edition. You can add on a little sub-program to create gears for you. So the only thing that it does, though, is it just plots the gear as if you were looking at it in one dimension. So it just gives you this edge. That profile there you see with the gears. So what I did is I made the bottom gear, and then I extruded it out, alright, and then I just twisted it on top and the bottom stayed stationary, and that gave me this nice twist. And also working through nylon, that was a whole new experience. But let's talk about the drawing process. You can actually see, especially if I hold it on the table, you see that curve up? If you look at the original, it does not have a curve, it's flat on the edge. It's round. This guy is actually curved. So that was my first dilemma, because in Google SketchUp, when you take this and you just turn it, that's what happens. It just turns it, everything's straight lines, there is no curve. So between trying to figure out if I had the right angles and if that was going to work right, and trying to get the nylon to stick to the bed, that was pretty tricky until I figured out the proper board material, which is basically a type of laminate. So this is another one. Again, it was peeling off the bed, so it was actually printing level, but it was peeling like that. And of course, same problem. And this guy actually goes here. I don't know why that one's like that, but anyway, so you can really see, once I got it stuck to the bed, you can really see that nasty curve. See that? That should be flat. That has to do with how the drawing worked out. So I ended up actually taking the drawing and actually drawing one. I took the bottom let me put this up here. So basically I took the bottom gear and the top gear, measured between them, took a half point, copied just the perimeter of the drawing of the actual gear itself, put it halfway between the top and the bottom, turned it to where it matched my angle right, and then drew a curved line through every single point in the drawing, and it's pretty extensive. I'll show you how many points are in that drawing. And I drew one whole angle piece, one whole tooth at that angle with curve by triangulation. Then I copied and turned it 14.2 degrees until I had made 25 of them around here. I actually happened to do that, I believe 3 to 4, possibly 4 times, 3 for sure, and that was a pretty extensive amount of work. But this is a result of missing the teeth. I thought I was drawing the right angle and ended up not drawing the right angle. Ooh, not happy. So I redrew it again, and that's where this guy came about, and it's really hard to see, but and it might be this way actually. This guy is actually too angled. It is hard to see. I colored these so you can actually see them, but you see how they're too much angled? So this is the proper angle. I redrew it for the last time, and you can see that indeed it's now flat for the most part. Actually, this one's probably a better example of this. The top is hitting, but it is flat. So it's actually a curved gear now, where prior it was not actually a curved gear. The edge is actually curved. You can see it turned out really well. And this is the one I just got off the bed. This is one that I was testing. It's actually too tall, but it's perfect. I mean, it runs so smooth either way. It doesn't take anything to turn that. And you can see there's not much play in there. It's pretty well a perfect fit. So total success on that guy. And pack this full of grease, and we'll be off to the races. So total success. And I do have a lot of other things I'd like to talk to you guys about with nylon, but that's going to come in another video. But basically I rebuilt my entire hot end to try to accommodate the nylon, because the original hot end had extra space in it because it was designed for 3mm filament, and I'm using 1.75. So Jeff modified it for me because he originally built the original hot end. So he modified it for me so I could put the right filament in it, but down in the actual metal part where you couldn't really patch that, you have to make a whole new one. So he just patched the top where the filament would work. There's too much room in there, and it would heat the plastic up, and nylon wants to expand when it's hot. and so it just expanded out the end and squirted everywhere, which is a bad deal. Also, moisture is a very, very bad thing. If you can keep the nylon in a closed container and just let it come out the top with some moisture absorbent material, I think that'd be a better idea. Because I had a lot of problems with printing at first where it's not really clear, and I did manage towards the end here to get some that were more clear. So, you know, lots of stuff with nylon, but all in all, this actually turned out really well, and I'm really pleased with it. And I think this guy's gonna have his speedometer back. So we'll see. That's it. More coming up later on the whole idea with nylon and what I did with it. But I wanted to show you. I might even post that first. But I wanted to show you that that was a total success. And that is the finished gear. The reason that this looks different, you're probably wondering why this is so different. This originally had tabs that stuck up here, which caught the actual part in the wheel. I designed it so the tabs just have to lock in here. They can't free float. They have to stay right in here. And that was just because I wanted to design this part to be a little bit more rigid. And I had to expand this out because the gear would want to walk left, right, forward, back, however you want to call it. But the gear wanted to walk, so I've got this precisely measured to where this gear can't really move around, but it's still free, but just barely. And that allows it to free float inside this housing right here. This one's actually a bit shorter, you can see. This guy, because that's the finished one. Same as this one. That's the finished one. This is the one with the wrong angle. Anyway, alright, well that's it. Total success. Just wanted to show you that practical uses with 3D printing. That's the idea here. Alright, peace out. God bless. Leave a comment. Bye.
Phlegm. So, some of you are going to ask me how strong these little gears are that I made. And, quite frankly, these are test pieces. I was still playing with temperatures and all that kind of stuff. But let's take some pliers and just apply some radial pressure. And just see what happens. Let's do it like this. Not on there all the way. Now, you gotta remember, these gears are not gonna be they're not gonna be in this kind of environment. So it definitely delaminated, but it did not break. There, it broke. See if we can get it to delaminate by twisting. It's trying. It's trying to come apart. Yeah. Let's do this one again. See if and this is at random temperatures and stuff, so that last one I printed is pretty darn solid. It's almost completely solid. Just see if we can break one side. I mean, it is delaminating, and that has to do with some of the temperatures and stuff that I was playing with. But as far as it actually, like, breaking, you know, where I'm bending it, it is not. So, hopefully that gives you an idea of how strong this stuff is. Lamination is going to be your biggest problem here, and that just has to do with temperature and your layer height. The last one I printed at 0.04875 layer height. Actually, I can't even hardly flex it. It's actually really solid. The layer height was so small that each layer laid down was pretty much melted into the layer before it. So there you go.